Okay, so what I'm going to do is I'm going to analyze this problem. Let's make sure we're aware of what it is. You've got 75 degrees, 67 degrees, and 9.1 centimeters on one side. You want to find out what x is. So what I'm going to do instead, before I decided to split it right down the middle like this, because it's easy to visualize. This time, I'm going to split it here. And again, one thing to be aware of is this is not to scale. This is not to scale. It's not to scale at all, mainly because you can see that this is not a 90-degree angle, yeah, at all. But I just, in a warped way, you could find the correct position to consider it a, it's not going to work, hold up, let's see if I can do this. Let's do this like that, yes, and like that. Look at that illusion for a second. You could find it, wait, hold up, bear with me one more second. Just take up one more second of your life there, something like that. So what I've done is I'm again, not to scale, considering splitting it so that there's two right angle triangles on this. That's the concept. That's what I'm doing as a concept. Now, in terms of this left side, the left side over there, I can very much consider this left side as a separate triangle. And what I would do is I'd say, well, now this angle, this yellow angle up here is, instead of calling it theta, we can just call it what it is, sine 75. It's sine 75. And it's equal to this length here, which is opposite. And I can depict that concept quite comfortably with my lovely little arrow here. Opposite that sine 75 is that line, which is why, therefore, I'm going to call this line here opposite. So this is my opposite side. Notice it will be the same opposite side for the green triangle. And this line here is x, and that would be the hypotenuse, the longest side of that red or pink triangle. And so I can say sine 75 is equal to opposite divided by x instead of hypotenuse, when before it would be opposite divided by hypotenuse, is now to opposite divided by x.